derived from the word acidus. Since this is the chapter acid, base, and salt, so first of all, we would be starting with acid. So the term acid is derived from the word acidus, which means sour in taste. Okay. So the substance which would be in sour taste, I would call it as an acid. So this is just like a physical property, like by just um tasting some chemical, like this is the lab protocol. We are not supposed to touch, we are not supposed to taste, we are not supposed to smell it. But we have lemon. In lemon
Citric.
we have
Yeah.
ascorbic acid. In lemon we have ascorbic acid. And if you can taste the lemon, so you will see the sour taste, which is going to represent that this lemon is going to have acid. So I'm talking about the general term acid. I'm not specifying what is the name of acid. It should be hydrochloric acid. It should be sulfuric acid. It should be
Yes, sir. Like citric acid, we tasted it sour in some
yeah,
snack.
exactly. So I'm not going to specifying any sort of acid. It's a general statement. So, but we have to define it. We have to define it. So acid is a substance which gives H positive ion. H positive ion. Whether you have HCl, whether you have H2SO4, and whether you have HNO3, okay, and whether you have any of the acid, remember all the acids are going to have this ion that is called H positive ion. This is also known as proton. This is also known as proton. So why this is called proton? Why this is called proton? Because
Because
if
it's
you can
positive.
see, if you can see, this is H plus, proton number is 1, mass number is 1. Okay. How many electrons it has? You will say 0.
Zero.
How many protons it has? You will say 1. How many neutrons it has? You will say 1 minus 1. That is equal to 0. So since it has only one proton, so this is known as proton. But you cannot call proton if you have only hydrogen atom. No, it's not a proton. When you can
It's
see
an
H
ion.
positive ion, this is called proton because it contains only one proton. So remember. So according to, we have multiple theories to define acids and bases. We have multiple theories, but according to the Lowry-Bronsted theory, according to the Lowry-Bronsted theory, acid is a proton donor. Means that every acid is going to donate H positive ion. So acid is a proton donor. Okay, so of course, HCl, it has a proton, that is hydrogen. Then we have H2SO4, then we have H2SO4, and then we have HNO3. So since we have any of the acids, so they are going to donate H positive, H positive, H positive. So these are called acid. We have a lot of acids, but few of them are HCl, H2SO4, and HNO3. They are famous acids. So they all are going to give protons. Some acids give one proton, some acids give two protons, some acid gives more than two protons, like three protons, but not more than three. Remember, H3PO4 is the acid which is going to give three protons. H3PO4. Okay, H3PO4, which is called phosphoric acid. So it's going to give you three protons. Um, and then you can see this one when I have dissolved HCl in water. when I have dissolved HCl in water, so then H2O is going to accept proton from this acid. You can see this. In the reactant side, it was H2O, but in the product side, it is H3O positive. What does it mean? It has accepted one more proton. It has accepted one more proton. So this is a proton acceptor. It's not an acid. Acid always donates proton. Acid always donates proton. So HCl has donated its proton to this one. So HCl is acting as an acid. That's the characteristic of any acid. That's the characteristic of any acid. So, most of the time, examiner would be asking, identify the ion. Most of the time, examiner would be asking, identify the ion which is present in all of the acid. Which is present in all of the acid. You know what you are supposed to write? H positive ion. You know what you are supposed to write? H positive ion, because you can see like different ions in an acid. Like let's suppose if we have HCl. So in this HCl you have two ions, H positive, Cl negative. H2SO4, you have two ions, H positive, SO4 2 negative. In HNO3, you have two ions, H positive, NO3 negative. But you can see one common thing. But you can see, but you can see one common thing, that is H positive. That is H positive. If you can see, H positive is present in all of the acid. H positive is present in all of the acid. Okay, like this is the common one. So if examiner would be asking that like identify the normal cation which is present in all of the acids, so you are supposed to write the ion is H positive. Okay, and then uh, we have different acids with different strengths, like some acids are stronger and some acids are weaker. Okay,
Weaker.
some acids are stronger and some acids are weaker. So strong acids are highly corrosive in nature. Strong acids are highly corrosive in nature. They
That's why
burn
you have
skin.
to add water.
Yeah, we have to dilute it so that it can become less corrosive. But still, this is a question that how we are supposed to add water in an acid, because, you know, should we add water in acid or acid in water? These are different things. Like let's suppose I have two beakers, this one. In this I have acid and in this I have water. So should I add acid in water? This is method A. Or should I add water in acid? This is method B. Or you are thinking that, sir, these are the same methods. We can do any one of them. So what do you think about that? Acid in water or water in acid? Yes?
So should we put water and acid?
Remember, all is well. All is well. Acid in water. Acid in water. Always remember. Acid in water. All is well. Acid in water. All is well. Are you getting my point? Okay?
Yes, sir.
Yeah. You know why? You know why? Because if you are going to do reverse, like you are adding water in acid, you are adding
Will it
water
evaporate?
in acid, it's highly exothermic reaction. It's highly exothermic reaction, so the acid can splash onto your face. The acid can splash onto your face. To avoid this, we are supposed to, you can say, add in a proper manner. We are supposed to add in a proper manner. So let me tell you some animation. You can see over there, okay, what would happen if you are going to do the reverse one. So see this. Okay. Yeah, see this one. Okay. See this. If you will do like that, so it can harm for you. It can splash because this is highly exothermic system. So that's why we always add
Acid to water.
acid in water. Remember, but not directly. Remember, you are supposed to tilt your beaker, your any of the apparatus that you are using. Tilt means just like that. So I would add acid dropwise on the wall of this container. So it would be slipping just like that. So slowly, it would be mixing with water. And we have to take care it basically, because all the acids, because, it's a physical property of acid that they are corrosive in nature. They harm, they burn skin. And so we have two types of acid. We have strong acids, and then we have weak acid. Strong acid means that the acid which completely ionizes in an aqueous solution when dissolved in water. What do you mean by ionization? What do you mean by ionization? Ionization means breaking down of any compound. When the compound dissociates, when the compound breaks down into two into two parts. Like if like let's suppose I have HCl, when it would be breaking down, so it would be forming H positive ion and Cl negative ion, of course. So this is called ionization. This is called ionization. This is also known as dissociation. This is also known as dissociation. And this is also known as breaking down of a compound. Breaking down of a compound. Okay. So strong acid completely ionizes. Remember, strong acid completely ionizes, fully ionizes. Like, what does it mean? Fully ionizes, completely ionizes.
It breaks
You
down
know,
into.
yeah, if you have 100 molecules of H2SO4, so out of 100 molecules, 98 molecules should give their H positive ion. Nothing is 100%, of course. Nothing is 100%, but out of 100, 98 molecules should give their H positive ion. So then I would say, yeah, this is a strong acid. But if out of 100, but if out of 100 only the 10 molecules are going to give their H positive ion, so I would say this is
It's weak.
a weak acid. Yeah. So, if this question comes in your exam, so at that time you are not doing an experiment. You are not standing in the lab. So how can you decide? So how can you decide whether this is a strong acid, whether this is a weak acid? Because you have to see whether the ionization is full or the ionization is partial. So this is a very important question. To to face this problem, you know, you are supposed to memorize which one is a stronger acid and which one is weaker acid. So here is a solution. Only these acids are stronger. Only until or unless examiner is going to give you any other acid. So he would be telling you about that, each and everything. But so far, These three acids are strong acids. They fully ionizes. They completely ionizes. We have seen them a lot of times. They fully ionizes, right? So when they fully ionizes, so I can say they are strong acids. It's very simple. Except these acids, like we have CH3COOH, that is called ethanoic acid. It's an organic acid. Like this is chiku, CH3COOH. Then we have H3PO4. Okay. Then we have H2CO3. Okay. Uh, Carbonic acid. So, these acids are weak acids, except this one. So you have to keep in your mind. Or like of course H2SO4 is a strong acid. When it ionizes, it gives 100% ionization, like H positive ion and SO4 2 negative ion. Like it's going to break down into the two ions, H positive ion and SO4 2 negative ion. That's it. And HNO3, it's also a strong acid. It's going to dissociate into H positive ion and also NO3 negative ion. Okay. Uh, and then weak acids. And then weak acids. So weak acid partially ionizes. Partial means nearly 10%,
Not completely.
15%. Yeah, not completely, of course. So if you have 100 molecules of any of the weak acid, so of course they are not going to ionize in a proper manner. In a proper manner, hardly they will be giving you 10 moles of 10 molecules of like H positive ion and 10 molecules of the negative ion. So they are weak acids. So these are example of a weak acid. This is weak acid. This is the weak acid. Okay. So what is the difference? So what is the difference between a strong and weak acid? Completely ionizes, partially ionizes. Good conductor of electricity, bad conductor of electricity. These are strong acids, these are weak acids. It's very clear. It's very clear. Okay? Are you getting my point?
Yes, sir.
Yeah. And then is there anything, is there anything that we can identify whether the acid is stronger or weaker? Like let's suppose if you are standing in the lab, if you are standing in the lab, so is there any chemical that I can use and I can say, yes, this acid is stronger and this acid is weaker. So, we have multiple tools. We
Yes,
have
sir. It's like
multiple tools. Yeah, we have multiple tools to identify whether the acid is stronger and whether the acid is weaker. So the first tool is pH. pH is a scale which is used to measure the acidity or
yes.
the basicity of a substance.
pH 1 to 2 is acidic, and then pH 7, like 8 to 9 is alkali, and then 6 to 7 it's neutral.
Yeah, and if it's seven, so this is
Neutral.
like neutral. Yeah, exactly. So, pH, like pH is a scale. Okay, pH is a scale which can identify how much strong acid you have and how much weak acid like you have. And also we have, let me tell you first about the pH scale. Let me tell you first about the pH scale so you can look over this. I'm going to share my screen. Wait.
Even, sir, with color we can identify.
Yeah, that's an indicator. Let me tell you this one. Okay, 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 okay. Yeah. Do you have my screen?
Yes, sir.
Let's suppose this is a pH meter. Let's suppose this is a pH meter. Okay. So uh, I'm adding like water. Okay. So of course, if I'm going to take a pH of that water, just like that. So the pH is 7, you can see over there. So the pH is 7. Okay. And I'm going to add, let's suppose, battery acid. Let's suppose I'm going to add battery acid. Since the water is 7, so I'm going to add battery acid. You can see the pH is going down. So when the concentration of acid increases,
pH
so the
decreases.
pH decreases. They are inversely proportional to each other. They are inversely proportional to each other. Okay. So I'm adding more water. So you can see the pH is slightly increasing because the solution is being diluted. When you have more acid, when you have more acid, so the pH would be higher. When you have less number of moles of acid, so the pH would be lower. Different species have different pH. Let's suppose we have milk. We have milk. So you can see what's the pH, 6.5. Then we have, you can say hand soap. Of course, you can see the pH would be basic. It's 10. So, so the pH scale is going to identify which one is a strong acid, which one is weak
Weak.
acid, which one is a stronger base, and which one is weaker base. So here is the diagram. You can see that you have to keep in your mind that if the pH is near to 7, if the pH is near to 7, so that would be weak acid and weak bases. Remember, if the pH is near to 7, so you can say acid is weaker and the base is also weaker. But if they are far from 7, like if it would be 12, 13, 14, so that would be a strong
Alkali.
base. Yeah, a strong alkali. And if you have 1, 2, 3, far from 7, so this
Strong
is a
acid.
strong acid. Yeah, this is a strong acid. In this level, you are not supposed to know more than this. That's more than enough. That's more than enough. What is pH scale? It's uh, it's a tool to identify the strength of base and the strength of acid. Are you getting my point?
Yes, sir.
Okay.
Yes, sir.
And afterwards, uh, then let's suppose I am going to give you some pH. I am going to give you some pH. Let's suppose. Uh, yeah, see this one. It's 4, it's 7, it's 10, it's 1, it's 2, it's 3. These are pH of different substances. Listen very carefully. These are pH of different substances. And then I'm asking, like, this is the information that is given to you, and then you have to identify the substance A, B, C, D, E, F. Identify the substance which has the highest concentration, which has the highest concentration of H positive ion. Highest concentration of H positive ion. So how can you decide? So how can you decide which species is going to have the highest concentration?
So is it one?
Stronger acids, so D,
One.
because acids are proton donors.
Exactly. Acids are proton donors. And also, I told you that pH is inversely proportional. pH is inversely proportional to pH is inversely proportional to the concentration of H positive ion. The concentration of H positive ion, remember. So D
Yes, sir.
means the pH is 1. D means the pH is 1. When the pH is 1, so means that concentration of H positive ion was higher. Concentration of H positive ion was highest. And when the pH is the highest, so it's inverse relation. So the concentration of H positive ion would be the lowest. Would be the lowest. Okay. So that's the main point. So examiner can relate. Examiner can relate the pH with the concentration of H positive ion. So and then afterwards, uh, this is the next tool. This is the next tool. It says universal indicator. So, so what is this? Universal indicator. Universal indicator. What is this? You know, universal indicator, it's a solution. It's a solution, is a brown colored solution, is a brown colored solution that can be added to any substance to find its pH. To find its pH. After adding few drops of universal indicator into the beaker, it which contains the sample can be any acid, the sample can be any base. Okay. Um, then you will see different color of that beaker. You will see different color of that beaker. So you will be providing this strip. On this strip, everything would be written. On this strip, everything would be written like this color is going to show the pH is 0, then the pH is 1 when you can see the pink color, so the pH is 2, and you can see the orange color, so the pH would be 3. So after adding universal indicator into the solution into your sample, and then of course your sample would be changing its color, then you can match your beaker with the provided list. That is this. So you can find the pH very easily. You can find the pH very easily. So it's quite simple. Okay, so it's quite simple. So let me show you how we can use the universal indicator. Okay, so let's see. I'm going to share my screen. Okay, 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 okay. Yep. Mhm. Can you see my screen?
Yes, sir.
Yes, sir.
Yeah, see this.
So now what I'm going to do, holding up pH scale here for the various colors, you need to take note of what color each one of the bulbs is. So you have that red at the beginning, pretty green. This one's blue. This one's a deeper purple color. This up here is pretty much the same color as this bulb here. So now what I'm going to do is I'm going to open up the valve again and we'll see what happens.
So basically the summary is that after addition of universal indicator into the solution, okay, after adding universal indicator into your sample, it may be any acid, it may be any alkali. So then, of course, you will see the color of your sample. So then you can match just like that he was matching. Then you can see the pH. Then you can see the pH. So that's also the method. That's also the method to identify whether you have a strong acid and whether you have a weak acid. Are you getting my point?
Yes, sir.
It's very easy, okay? It's very easy. So, physical properties of acids. Physical properties of acids. Acids are liquids at room temperature, first of all. Acids are liquids at room temperature, okay? And they are corrosive. They are good conductor of electricity. They are soluble in water and they turn blue litmus red. They turn blue litmus red. You know, there are two concepts. Number one, whether whether uh, you are going to identify strong and weak acids and whether you are going to identify only the presence of acid. That's the different topics. Try to understand my point, what I'm saying. We have two different concepts. Number one is that are you going to identify strong or weak acid, or are you going to identify only the presence of acid, that whether you have acid or not? If you are going to identify the strength of acid or strength of base, so you can find the pH and you can use the universal indicator. But if you are going to identify only the presence of acid, like you need answer in yes or no. You are not interested in whether you have a strong acid or weak acid. You are not interested in that one. You are only interested in to see the presence of acid. Yes or no? Yes or no? So we have other solution. The solution is that you can take litmus paper. You can take litmus paper.
Sir, is it red
So
in color?
uh, if you would be taking blue litmus paper, if you would be taking blue litmus paper, so it would turn into blue for the sorry, if you are going to have blue litmus paper, so it would be turning into red. If this would happen, if this would happen, so remember, it means that the acid is confirmed. It means that the acid is confirmed. Okay, I am having blue litmus paper and I am going to take this litmus paper into that beaker in which the acid is present. So I would see that the color of that like the color of that litmus paper would be turning from blue to red. If this is done, so yes, I can say acid is present. Acid is present. And we have multiple other things that are known as indicators. That are known as indicators. You know, we have phenolphthalein as an indicator. We have phenolphthalein as an indicator. You know, when you would be adding phenolphthalein in acid, it would be colorless. It would be colorless. Or also we have other indicators, including methyl orange, including thymophthalate. We have multiple indicators. Remember, we have multiple indicators. So we can identify very easily the presence of acid and the presence of base. I would be providing the list of that indicators, that what would be the color of that indicator in acid and what would be the color of that indicator in a base. So they can also tell you the presence or absence of any acid. Are you getting my point?
Yes, sir.
Yeah. So, and then you can see, um, okay. Yep. Then we have base. I would be telling you the chemical property after the physical properties and the definitions of acids and bases. So what is base? Base means that base means that the substance which is a proton acceptor. The substance which is a proton acceptor. Okay. Like I gave you an example when HCl were reacting with water. So the water was accepting the proton. Since the water was accepting the proton, so the water was a base. So water was acting as a base. It's quite simple. So we have two different terms, base and alkali. You know, you can say that the term is different, but the meaning is the same. Both are bases. Try to listen carefully. Both are bases, but alkali is water soluble base. Alkali is water soluble base. Like let's suppose I have given you this thing, ammonia. I have given you ammonia. Okay. And I am asking, is this a base or an alkali? So you know how can you identify this one? You have to
Alkali is
dissolve
soluble in
in
water.
water. Yeah, you have to dissolve ammonia in water. If it's going to dissolve in water, so you are supposed to say, sir, this is an alkali.
Alkali.
And if this is insoluble in water, so you can say, sir, this is a base. So what is the difference? When the base is soluble in water, so we give the special name to that base, which is alkali. Are you getting my point?
Yes, sir.
Yeah. So should I say that all alkalis are bases? Should I say that? But all bases are not alkali. Should I say that one?
Yes.
Yeah. Because let's suppose ammonia is an alkali. Is this a base? Yeah, this is a base. But
Yeah.
since it was dissolved in water, so I gave the special name to this one that is alkali. That's the that's the difference between base and alkali. So okay. So they are proton acceptor. That's the definition of alkali. That's the proton acceptor. And just like acid, we must know the difference. We must know the identifications of base and alkali. Like I told you in the formula of acid, you will always see the presence of hydrogen. In HCl, there was hydrogen. In H2SO4, there was hydrogen. In H3PO4, there was hydrogen. In Chiku, there was hydrogen. In H3PO4, there was hydrogen. In H2CO3, there was. Whether you have a strong acid, whether you have weak acid, there would be hydrogen. So you can identify acid very easily by looking at hydrogen. So there should be an identity of a base as well. So yes, there is. If you can see, if you can see oxide and hydroxide, that's very important. This is the exceptional case. In this, we have hydrogen, but this is not an acid. It's a base. This is exceptional case. Okay. Rest of rest of this ammonia, uh, except ammonia, if you can see oxide or hydroxide, oxide or like let's suppose sodium hydroxide, magnesium oxide, aluminium oxide, potassium oxide, calcium oxide, metal oxide, metal. So then they are bases. This is base, 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 oxide, hydroxide, and also the metal carbonates, and also The metal carbonates, let me write this one as well. Carbonates. Carbonates. They are also bases. Okay. Like let's suppose sodium carbonate, Na2CO3. Okay. So yes. Can you tell me, potassium oxide, is this a base or no? Mhm.
Yes, sir.
This is a base. Why? Mariam, can you tell me why this is a base? Yes, Mariam.
Maria.
Mariam, you're silent. You're muted. I think she's sleeping.
Maybe so.
So, potassium oxide is a base. Yes. Why? Because it is going to have oxide. It is going to have oxide. So this is a base. And what about this one? And what about this one? Yes,
So is that acid?
really.
No, sir. It's not a base.
It's a base.
No.
So
It's sodium chloride salt.
salt, exactly. This is the salt. This is called the salt. It's neither acid nor
Nor
base.
base.
Yeah, exactly. So, because it's not going to have any hydrogen, I can't say that this is an acid, of course.
Yes, sir.
And it doesn't have any oxide and hydroxide and the carbonate. So this is not a base. This is the salt. This is this. So you must be good at in identifying the presence of acid and the presence of base. Okay. So generally group 1 hydroxides are soluble. Group 1 hydroxide. Group 1 hydroxide means that lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium. So they are soluble in water. So they are called alkali. They are called alkali. They are called alkali. And group 2 hydroxide, especially calcium hydroxide, it's insoluble in water. It's insoluble in water. And also the magnesium hydroxide, like it's insoluble and this is partially soluble, like it's having a less solubility, not completely insoluble. Magnesium hydroxide is a base. It's not an alkali because it's having a poor solubility in water. Okay. So you must know the solubility as well. Which one should be soluble? Which one should be insoluble? Which one should be partial soluble? Because if you don't know the solubility, so you cannot predict the presence of acid or a base. Okay, so they are hydroxides. So they are bases, bases, base. Yeah, then moreover, if the examiner would be asking that you have to identify which one is base and which one is alkali, then you need to look at the solubility of that particular substance. Okay, like ammonia is soluble in water. Can you hear me?
Yes, sir.
Okay. So what I was telling you, yeah, generally we don't have weak alkali because uh, alkali are like mostly they are stronger. Mostly they are stronger, right? Whenever I use the term alkali, so I mean to say they are always like stronger, generally speaking. Because in an acid we use the term you can say it's a strong acid, it's weak acid, but in alkali, generally the alkalis are stronger. But I don't want to say okay, we never have weak alkali. We have, but very few example you will see over there. And also, after discussing the physical properties of acids and alkali, so you must know the difference. Like you must have a comparison between the physical properties of acid and the physical properties of alkali. You can see colorless, sour, bitter, corrosive, turn blue into red, red into blue. That's the only difference. That's the only difference in the physical properties. That's the only difference in the physical properties. Are you getting my point? Okay. Okay. Can you hear
Yes,
me?
sir.
Yes. Okay.